In fact, I was going to send that.
Let me go get to you before it's time, yeah? And we pick up the blue cheese?
La idea, vamos a ver, tenemos media hora, o sea, tenemos una hora. Pero vamos, que la presentación es un poco los cambios y pues ya está, ¿no? Y decir que vamos a ir al IETF y ver qué dice la gente, pues lo mismo Sara tiene algo que decir. Ya, yo digo de mi parte, el resto no están más. Well, we will start in the moment we have Sarah in. She told me that she was going for a cup of tea. So, okay.
You're waiting on me?
Yep.
Oh, sorry.
Don't worry. Don't you mind to close the door? Would you mind to close the door, please? No, it's the guy who's in.
Thank you.
Thanks. Okay, welcome. This, as you can see there, this is the Nfvrg meeting. This is going to be, according to a little bit shorter than those of you who are part of the usual suspects will remember. This is going to be a just 1 hour meeting with one presentation on technical matters, the discussion of one document, and some open mic period on what to do in the coming times of the year with the research group. So just as introductory, this is to remind you about the IETF IPR policy. That is essentially the same as at the IETF. As Adrian said this morning, you have to remind that everything you say here is a contribution and is under the IPR policies. Be aware of that. This is the usual call for collaboration in reviewing documents. And these are some data about where we are, what are we doing, where you can find some the mailing list, the slides, where are available for you, and the web and the wiki that is a little bit updated, I must confess, and needs some work. It would be great to have someone taking notes.
We have a tradition in BMWG that anybody sitting in the back row is an automatic note taker or Jabber scribe. So if you sit in the back row, I guess you're signing up? Yeah? Gentleman looking at his phone over there in the left-hand corner? No? No hands? No beer? Can we bribe you with a beer? No takers.
We don't have John, we don't have Dirk, who are the ones that who are. Oh yeah, but I would like to have. Second call. Come on, it's not so difficult. Okay, that's something that we have to learn, that we have to ask in advance, and not because apparently, well, we'll take. Then don't complain about the agenda, the minutes not reflecting exactly what you. Okay, so let's move on. This is the usual request that whatever the research events you are aware of, just use the list. But use the list only for research events, limit it not to just to make announcements or whatever of other matters. And if you have any doubt, ask us. If you news about, you know, and in the list we discussed about this in Chicago, and we have been discussing in the list. We're about to send our first document to the IRSG for publication. And we are, now that we have under this milestone, one of the ideas that we were discussing with the IRSG chair was precisely to refocus a little bit the activity in the group, focusing in a few matters that are suitable for produce research results in the midterm, to try to organize shorter meetings but more frequent, not limited only to the gatherings here in the IETF meetings, trying to assemble the group or part of the group in the opportunity of a scientific conference, etc. And well, we will talk about this later on the agenda. And a few remarks just for you to be aware of this. One is that there was, before this session, there was a ball for network slicing, in which, one of the things that I would remark is that Adrian Farrell highlighted that the IETF is not a research group, and that many of the problems that were discussed during this afternoon on network slicing probably would have to do with our concerns here in the Nfvrg. So just consider this as a potential input for what they're doing. Later this evening, there was a meetup on distributed infrastructure, which is about, and I will say it, blockchains, basically, blockchains and related distributed mechanisms. So if you're interested, I can bring you to the meeting place. There is another BOF or I'm not sure if it is a formal BOF on identity enabled networking. On another the proposed research group on path-aware networking, where precisely Nfvrg can have a role to play. During the bits and bytes, there will be a demo of the 5GX project that, if you remember from the previous meeting in Berlin, there was these robots that were dancing around the lines, and they were cloud-based and running a service chain based on Nfvrg, which is an improvement of that. There is a presentation on this Friday on STAR, which is something that I believe could be used for establishing trust in an Nfvrg environment. And there will be a barb-off on edge computing. No, I don't know exactly where, but again, if you're interested, just tell me. And whatever you want to remark, I would be glad to include it here. Well, moving to the agenda. First, we are talking about this, we are in the welcome. Then we will have Carlos presenting the drafts on challenges towards IRG discussion for publication. And then we'll have a talk from Wolfgang Kellerer on flexibility as another measure for in the case of Nfvrg. And finally, as announced at the beginning, we will be talking about a little bit about the future and how we will achieve this refocusing of the Nfvrg. So before we start with Carlos, just let me remind you that I gave the blue sheets in both wings. If you can pass it to the center, it would be ideal. Where are the blue sheets? If you can move it to the, yeah. And in the other side, can you move it to the center? Okay, so let's move on. Carlos. So you don't have to tell me about next slide. Yes, take this. Should work. Now I have to find where your presentation is. Yes.
Okay. Thanks. So my name is Carlos Bernardos. I'm presenting this short update on the draft on the research challenges. So this is a brief recap of the history of the draft from individual submission back in Prague, actually in IETF 93rd. And then it was adopted in Yokohama, well after Yokohama, and has been reviewed several times and gone through several revisions. And here we are in version 06. Brief recap also on the main goals of the document. So the main goals are to identify some research challenges in the area of network virtualization based on a gap analysis that we perform, and then that document may be used as a basis for new activities that are still not covered in IETF, IRTF, covering those challenges. And in this version, as we will briefly show later, we also try to match those research challenges, those gaps, with the focus areas that we are discussing in the group. So this is the structure of the draft as of today. In red, I'm trying to identify the changes, the new sections that has been introduced. This has been based on the reviews that we got. We got 9 reviews since the previous version, so thanks for all the reviewers. I'm listing them in a subsequent slide. So we introduced some additional background on ITUT SDN functional architecture. We did some updates on the MEC due to the changes that have taken place on MEC. We removed IoT section because that was more of a use case section there, so we moved the content more in the challenges where we believe it fits better. And then in the challenges, we introduced one, again, as a result of one of the comments from the reviews on network function placement. And then in the last section, section 6, we adapted or evolved that in order to better suit the new focus areas discussion that we are having in the group. And there have been many other changes in the content itself based on these reviews. Here is the list of the people that provide those comprehensive reviews. So again, thanks a lot for all the comments. And I'm not listing all the changes because there are quite a lot. We try to address all the comments. Basically, in addition to these changes in the structure, we also try to put more academic references. This was something that was requested by more than one reviewer, so we tried to do that. And well, basically, this is also an update on the gaps and the potential IETF efforts after reviewing the new content with the new section. So this is the table there. There are more details, of course, in the draft. And the update that we did regarding the focus areas, how to match the open research topics that we identify based on the gap analysis into these 4 areas or 4 focus points that was proposed on the mailing list. And this is basically it. We got very positive reviews and very comprehensive reviews. So we believe the authors of the document that we address all the comments and that the document is ready to go into the next phase for the publication. So if you have any comments or questions?
So I don't know if I have to formally say if you have any comments or questions. So, so the idea is that now we will formally announce in the list that we're going to Nfvrg, and then once after, I don't know, a week or so, if we don't receive any strong objection on anything that is allows. No.
I just, Arnaud Tadei, just one question. I observed a comment on the definition based on ITUT. Is it study group 13?
Is
it study group 13 in ITUT?
I don't remember. We got some pointers from Dirk. I don't remember exactly which group right now, but we used those pointers that were provided on the list by Dirk von Hugo from Deutsche Telekom. I don't know if he's around. Yeah, so then it's 13, yes.
Thank you. By the way, I started to take notes. It's the first time I'm back at IETF after 20 years, so I will need a little bit of help to make it correct.
Thanks.
So this is double thanks to you. No, 2 years. Yes, exactly. Sarah reminded me. Any other comments? Okay, so thank you, Carlos. So I will announce it through the list and we'll move this forward. Well, we are doing well in terms of time, and well, our next speaker is Wolfgang. He's from the Technical University of Munich, and well, he has been working for a while in something that I think is when we have been discussing about the different ways in which we should work. One is our measurements. The point is that measurement is something that is being well addressed by working groups in the IETF. But precisely this is I think it's an interesting opportunity of measuring something different, but it's equally important probably. Please.
Okay. Yeah, thanks, Diego, for inviting me. So what I'm presenting here, or what I'm going to entertain you a little bit at this late session here, is about measuring something different. Because in a larger project that I'm started and have not finished, this is a 5 years project, I'm just in the 2nd year now. What we are doing here, we are thinking about measuring flexibility, which comes at utmost importance now in all respects, in network function virtualization, SDN virtualization, and all these things. And let me try to take you on a journey, what we are doing. I have more examples than basically I have then detailed equations or something like that. So let's start the journey at where we are. And what we face, and that's also why we are here, for network function virtualization, we face and we see the network coming with new requirements. Vertical industries, dynamically changing user behavior, global digitalization, and so on and so forth. What is less addressed nowadays is the flexibility to react to these dynamically changing requirements. And in the end, less the adaptation of the network is of a concern today. But actually what we know is that those species, they prevail in the environment that are most flexible to adapt to changes. We know this from us, so we basically can handle anything. If this is good or not, we can discuss at another point, but we are quite flexible to do something new. This is also what we do in research. And this is something I would like to bring you now, how this can be reflected in networking. I will start presenting, after some more motivation, our idea of how flexibility of a system can be measured. The idea is really that you have a design choice A, you have a design choice B, and now you're not asking for performance only, but you're asking for which design choice is more flexible than the other one. Because I might in future face requirements, new requests I don't know yet, and how can my system support them? I have a bunch of use cases with me, depending on how much time allows, and this is research. I'm probably raising more questions than I can give answers at this stage of the project too. So let's start very basically. Of course, we all know, we are here at IETF, that the internet is able to adapt resources. Somehow, we have best effort, we have TCP, elasticity, BGP, OSPF, and so on and so forth. However, the early days simplicity has somehow evolved what we call some ossified system. Adaptation is slow to new requirements, and in particular reaction to dynamic changes, as we can see here, the pointer is not so well, is very difficult to do, but we are faced with more and more changes, more and more reasons for adaptation. I'm now not arguing for a future internet. I'm just arguing and showing you, well, we have tools now available. These tools are network function virtualization, they are software-defined networking, and those tools actually address this. I'm not presenting now new concepts for flexibility, but we have these concepts. They promise to create and adapt networks and functions in software. We call this also network softwareization. You all know this. So you have, in this example here, you have some traffic, and we have here this green flows, and this yellow flow is coming, and then we shift via some controller, via some orchestrator, network, a slice or the network flow to other places, and we also shift network functions there. So we can react to these changes. So everything fine? What I'm doing here? Well, now the questioning starts. Are all problems solved? Are we already fully flexible with these concepts? The question should rather be, and this is what we should ask in particular as academics, how far can we go with this flexibility? What is the right network design that gives us more flexibility than another network design? And this is what we are targeting in our project. We are striving for a more fundamental understanding of how to provide flexibility. And we are even now, I will show you a first glance on a quantitative measure for flexibility for and against certain design choices. So what is flexibility in networks? Well, it's like in everyday life. For networks, we say it's the ability to support new requests, so requests that were not given in the set of requirements when the system design has been built. So to support new requests, to change design requirements in a timely manner. Now, design requirements might be changes, might be traffic pattern that are coming. You've seen this in the previous slide. That might be change of latency requirements, low delay, 1 millisecond, and so on, and in a timely manner, because time matters. If I allow you infinite time, everybody might be able to do something different. But we would like to have it quickly done. And how we can do this is because the system design allows us to adapt network resources, topology, capacity, and so on, if needed. Maybe the system design is in a way that we don't need to migrate any function because they are already in a perfect place in order to serve new requests. Now, a very first definition of our flexibility measure could look like the following, taking into account of what I said. We measure the flexibility phi t. T stands now for the time, for the timely matter of a system S as the supported new requests within a given time over the total number of given new requests to the system. So we challenge the system with new requests, and then we simply count how many requests the system can fulfill in a given time, so that it allows us to compare a system A and a system B, of course, under the same given requests, otherwise we are not comparable. So the fraction of the number of new requests in a certain time interval. Time matters, but of course, what we know, when we move the time to infinite, then we also get some glance on the system. Then it's basically how many requests can we support over all given requests. So this is basically then approaching to it when we do time to infinite. Okay, so think about this one. This is now a proposal for how to compare different designs for flexibility. Let me show you now with a very simple toy example, of course with some network functions, of how this could work. Let's look at a very, very simple network. We have 4 nodes. The node capacities NC are 1, 1, 2, 3. And we have a controller, could be an SDN controller. There, you see this is residing at the left side. And this SDN controller is now requiring a larger capacity. So the new controller capacity, because it has to do more, is now suddenly requiring a node capacity of 2. Now the question is the system flexible enough to support this new request? For example, we could migrate the controller to a node with a higher capacity. And now there is some time constraint. This should be quick, and we only allow, now for simplicity, I don't have seconds, I have now time in hops. I say we only can allow to migrate 1 hop over 1 link. Would this be doable? Well, with this migration time, it is doable. We have 1 node, 1 hop away, which has a node capacity of 2. So we are able to say, yes, this request can be fulfilled. And though we can count, our phi is 1 new request supported over all given new requests. Of course, this is a bit boring if I only have 1 request and this one is fulfilled. So we can extend this, and say we have more requirements, more new requests. At the left side, we have this one we have just seen. In the middle, we say now the new controller capacity required is 3. There is a node that has a controller capacity of 3. However, this node is 2 hops away. So time constraint not fulfilled, not flexible given our limited time. And on the right, we have a controller capacity demand of 4. New requests can also not be fulfilled because there's anyway no node in this system. So what we can say, toy example, we have 1 new request supported out of 3 given requests. So we have a 33% flexibility of this system with these given requests that we have in mind. If we now relax the time and we say we don't care about these time constraints, we put the time constraint to infinite, then you see it in the bottom row. And if you're not constrained in the number of hops, then we can see that also the middle one can be supported. And in the end, we have 2 requests out of 3 given new requests. So we have 2/3 or 66% of flexibility of the system if time doesn't matter. Now you've seen some glance on this flexibility as a measure. Now you might ask yourself, how would this work? Now, can I compare flexibility with flexibility? Isn't this apples and oranges? Yes, you have to be careful. Flexibility as a measure, as kind of a quality of flexibility, is similar with quality of service. And we cannot say, I have more data rate, you have lower delay, that's why your quality of service is higher than my quality of service. And similarly, for flexibility, we also have to decide case by case. We propose flexibility aspects, and we say, in order to be able to quantitatively compare different systems designs, we have to say, we are comparing these systems with respect to their adaptation flexibility on flow steering. like with software-defined networking, or with their flexibility on function placement. How easy is this system with this algorithm allowing us to place and replace functions in a very quick manner in order to be adaptive? And exactly on the latter case, I brought now some example to illustrate you a little bit in more detailed what this is about. And this example is about a more complex example than before, where we have applied the flexibility measure. The next 4 slides are just to bring you all up to speed what this example is about. It's about network functions, it's about complex network functions in an LTE, in a 3GPP environment. But you don't have to be experts in the 3GPP architecture, even if I show it here on this slide set. What you see here marked in yellow, this is network functions that we have in the 3GPP LTE architecture that have both data plane and control plane, so complex network functions. And we look at them, and we apply different concepts for them to make the whole system a little bit more flexible. And then we measure the flexibility afterwards. So these are gateway functions, they have data plane, they have control plane. Now what we can do is to be more flexible, we can take those functions. Nowadays they are sold in racks, in hardware, special hardware with these functions on. And using the concept of network function virtualization, we have a data center, we just move the whole gateway function into the cloud. We need some network element there, we have a virtualized gateway. Then of course we have to take care, of course, there is some data plane latency now because we have to move all the data in the cloud and back. And also we have maybe more network load because we have to move all the data into the cloud and back. Could be a good solution. There is another solution if we are concerned with the network traffic and the delay, that we can try this separation of concerns, separation of data plane and U plane, more the SDN-like concept, move the data plane back on the network element. And then we have a decomposed gateway. We have less data plane latency because we don't move the data plane in the cloud. We are just concerned with control plane. The question is, what is the delay here, for example, or in the effort? We don't know yet. This is something we have to find out. The thing grows more complex because we have more of these gateways. Now we have to decide, do we all move them into the cloud? Do we all move the data plane back? Do we have a combination of them this way or the other way, and so on and so forth? I don't want to go into the detail. It's a complex function decomposition and function chaining and function placement problem. We've run a lot of studies. This was a paper published 2 years ago at ACM SIGCOMM in a workshop. We coined there the function placement problem, where we ran a huge simulation on several topologies to find out which of these concepts is better with respect to performance and with respect to latency. And now I take this example in order to run another measurement and try to find out which of these is more flexible. So again, remember, we have these 3 possibilities. We can have this SDN design, keep the data plane down, only move the control plane into the cloud. We have the Nfvrg design. We basically move all the gateway into the cloud, and then we have to put all the data plane traffic into the cloud, or we can have a mixed design. Think about it. What you think would be your favorite? What concept would be more flexible than the other one? In order to find out, we have now challenged the system with new requests. Whereas the systems might have been built for a certain latency in mind, we are now challenging the system with different latency requests. The system has not been planned for, and we vary the data plane latency and the control plane latency, each with 10 different delay limits. 10 by 10 is 100, so we have now a baseline of 100 new requests. Now you can see easily I'm hinting at some percentage when counting the number of requests that can be fulfilled in the end to compare the different designs. We're calculating phi of the placement of these functions over these different designs as basically the sum of the feasible solutions over the sum of all solutions, in total 100. And now this is the outcome. I don't go into details. This all can be read in the paper. We had this at the Infocom workshop published last year. What do you see here? We have now different boxes here, different plots, different rates on whether we are more interested in the data plane latency or whether we are more interested in the control plane latency. Two things we can see. We can first see that a mixed, in the left side part of each of these graphs, that a mixed SDN NFV design is more flexible, because we have here a higher flexibility up to 60–70% of the cases. This is also what probably you thought is right, because mixed always sounds like more flexible. It is what you get. However, there is something written, I'm not sure if you can read it, underneath, logically centralized here, 2 data centers. What I didn't tell you before is we also tried with different system parameters. And on the left side, we only allowed 2 data centers on which the functions can be placed. And there, of course, the mixed deployment can make most for the flexibility. However, we also found there is a cap. If you throw 8 data centers at the system and allow 8 potential places in our US EBILAN network that we used, then there is not much of a difference with respect to flexibility with these 3 designs. You can use the more SDN, the more NFV design. Each of them can handle a similar amount of requests. But of course, be aware, there is cost behind it. So we need to consider the cost when talking about flexibility. So for distributed data centers, all 3 designs are equally flexible. Now you might ask, where is the time? He tells us now something about flexibility, and he says, given a certain time threshold, this has to be done. Well, this was another first example, and on this year's Infocom, we had another publication where we were striving now for a dynamic placement of functions. Not with these difficult, more complex examples from CGPP, but we just took, as before, an SDN controller as a network function in this second example. So you all know the controller placement problem. We place 1 or n SDN controllers. We now say this is our dynamic controller placement problem. We place SDN controllers for time varying traffic input. And of course, in order to optimize the delays from the switches to the controller, we need to eventually migrate controllers or reconfigure the system. And this is what we have done. We again used some US topology, 11 nodes, 14 links. Our new requests were now 100 randomly chosen traffic profiles, requests for flows into the system that required controllers, in order to be most efficient, to migrate. So we compare now a system with 1 controller, 2, 3, or 4 controllers in order to find out which one is more flexible. And you can already think about which one is your favorite. Do you think the one with 1 controller or the one with 4 controllers is more flexible? Flexible with respect to what? Well, we have an algorithm running after each flow that finds the optimal controller placement and flow to controller assignment, minimizing the average flow setup time. So this is our performance indicator. We would like to minimize the overall delay in the flow setup in the system. And now we check how many controllers can be migrated in a given time t. This is our limitation. And this is our flexibility. As we don't know what will be a good time t, what will be the limit for allowing a controller or several controllers to migrate, in our analysis shown on the next slide, we simply vary through the time. And then you can see with respect to which time threshold, which of these designs with 1 controller, 2 controllers, 3 controllers, 4 controllers is more flexible. So which setting of how many controllers can accommodate, can support more of the new requests of these flows, flow requests that are coming into the system. And this is what I show here. In this draft, on the upper one, you see the flexibility. This is the migration success ratio. And you can observe 2 things here. Blue is the system with 1 controller. As we have a very, very short time constraint, 120 milliseconds here. Even with 155 milliseconds, we can observe that 1 controller is surprisingly more flexible in these cases. What you probably thought is the 4 controller cases, if you relax the time, but still it's a tough time constraint, a little bit more, then for considerable t, more controllers are more flexible. What does it mean? If you have very, very strict time constraint, keep the controller in this given setting at the place, and you can then serve still a decent number of designs. However, what is the trade-off of this flexibility? As you can imagine, without migrating the controller too much, performance is not very good. And this is what we show in the lower graph here. So performance now, lower is better. This is the average flow setup time. You see here, the blue is always staying here at this level. It's not really performant. This is also what you can expect. But now it depends what you would like to have. Do you would like to adapt to a certain situation? Would like to migrate, always have the best, or rather be careful with your time and keep the tight time constraints. What we also find out is that there is a cap in the gain. We're not showing this here, a cap. You see also a little bit in performance, this cannot improve. There's also a cap in flexibility. And what we don't show here, when we go back, migration is also at a cost. And at some point, we don't gain any more in performance or in flexibility. The only thing that is rising is the cost, because we more or less migrate. Now, this is also something that has to be taken into account when considering flexibility. And so far, we have not seen this in most of the publications to taken care of. And this slide brings me basically already to a sum up what I have said. So what you should have understood now is, of course, this is what you know is, we are faced with new requirements in networking research from all these emerging industries and so on and so forth. And this is what you know, flexibility is a key point. We actually surveyed, and in the past SIGCOMM papers, 1/3 of the papers mentioning flexibility somehow as some of the design goals. But only very few of them actually say how this flexibility is reached. Now, we all know that with network softwareization, NFV, SDN, and so on, this is key technologies for this flexibility. But however, whenever we use new words, we ask ourselves, what does it really mean? What is a fundamental property of this flexibility? So we argue there is a measure needed in order to be able to compare different designs. And this is a first proposal. As I said, this is part of a longer project. I'm now in the second year of this 5 years project. And I would like to put this out to the community. Also give me your feedback, what you think about it. I think it is very important to get onto the flexibility and to be able to compare different designs. What I have not shown today because of limited time is also be aware that this flexibility measure is only valid with respect to performance and in particular cost. So we don't know yet in the green line how flexibility is evolving over different designs, and whether the cost, is there a key point where we say, okay, there's a break even, or even the cost is then rising to infinite. These are things we are still working out with use cases and examples. At this point, I go back to the key takeaways. Thanks a lot for your attention, and I'm happy to take questions.
Okay. Thanks, Wolfgang. Now, go to the mics. You will be.
Please.
I'll be first. Dan Drutze, AT&T. Very interesting subject, and actually, I agree with you that it's an important topic. But I think it's a complex challenge. And initially, when I saw flexibility on the title, I thought about something else. And I'll get to that. But I think one of the challenges that I see with this, and considering as a measure, is the fact that it really depends on the function, what flexibility means. So you can, and depends on the function and depends on the implementation. So I'm really curious, who do you think the audience of this measure is? Is that the vendors that we put RFPs to? Is it the internal design organizations within the network operators that are deploying these things? Is it just the research community? I'm really trying to understand, okay, I got a measure, assuming that we got the answer. Okay, so what do I do with it? And what that measure means. Is it 100 kilometers an hour, versus 50 kilometers an hour? What does it mean? For a car, I know what it means, but for your example with a gateway, I think it makes sense. But if I take the same measure, apply it to a totally different function, that measure won't stand. And so what I thought was flexibility, and maybe this is something you can look into, is as we're migrating to cloud-first solutions, the flexibility, it kind of comes down to the granularity and how you compose and decompose things, and that gives me more flexibility. How I design them, I can spread them out, I can keep them together. If I can have a solution that allows me to do all these things, but it's my choice to choose that flexibility, that's up to me. And then if that comes with some measures associated, that's even better. But I just kind of found that something was missing, and I know it's a long journey, so yes, right. Good luck. Thank you.
Thank you. It's a long journey and a lot of questions that you put. Let me try to take maybe one or two just to clarify. So you're totally right that we cannot take this flexibility as a measure as saying you are flexible 80%, you are flexible 70%. That's it. So I try to hint at that, and there is a more complex thing behind it. I just didn't have enough time. Now we have here whole theory behind it, and also a mathematical foundation for that. We have to use these aspects. And exactly as you say, there is a flexibility in decomposition, there's a flexibility in flow steering, there is a flexibility for function placement. And we can only view them in their area. We can also not say, and this is what I try to explain, your quality of service is better than his. You would probably ask me, what do you mean? Do you mean my latency? Do you mean my data rate, or what? And similarly, I think for flexibility, we have to go with that. We might have, in the end, some challenges. Is it what we are striving at for which case, which kind of request set, and basically request distribution can be used. And then the idea is really giving a tool to the vendors, to the operators, so they are aware of this flexibility. Because in the end, it is something that we always wanted, but nobody really could put it into numbers. And in the end, it was always the cost, and the cheapest system was then bought. I had worked for an operator myself for quite some time, and I had struggled a lot in the research department with this flexibility versus cost. And that's why giving some tool where you can argue to your boss, but we are now more flexible. Hope it helps. And for academia, pay a little bit more attention, yeah, to the flexibility, not just use it as a word in your publications.
Roland Schott, Deutsche Telekom. My question is related to the previous in that way. As an operator, we have, or my question was originally, is this measure so flexible that I really can compare two vendors or different designs in it to have here a clear view? Probably I define the parameters, the input parameters, but only an aspect. We as a company, there's a new department called design to cost, things like this. And if we have here also some parameters who in a way allows us to, in a way, assess and compare vendors, implementations, designs, where to put things. These are exactly questions that we currently also investigating and try to find solution. And my question is have you the aim also to implement this and deliver some feature or standardized functionality that I really can compare flexibility? Possibly there are other parameters which makes here it more objective and a real comparison, so that I can now conclude, okay, here I have less flexibility, but it's cheaper, and so I have, this is my question related to this. Is this the idea?
The idea is to get from, now this is quite subjective, yeah, because we need some basis in order to, some baseline, yeah, a basis where we can make this comparison too, yeah. We're trying to get as objective as we can. I'm not sure if we ever will find a flexibility where we can just compare two totally different designs, because the subject and the objective, yeah, of this design, what was this design made for? This is an inherent feature of the flexibility measure. But what we are doing at the moment, this is what I can say, what you can also see in some of our publications, we're trying to get as many cases, yeah, gather together cases, try our measure, and please do as well, yeah, in order to see what would be the fundamental parameters that are most important as a design criteria for flexibility, and maybe there are others that are less important, and then we can come up with, yeah, a baseline of, let's say, parameters and features that need to be taken into account. But it's quite complex.
And then I have an additional question now coming. You mentioned that this is an ongoing project for 5 years. Is this an internal university project, or is it a project who is a sponsor of this project?
It's one of those projects that where the EU is currently funding you as an individual researcher with quite some money directly for your research group. You're kind of free what to do. This is an ERC grant, if you know what this is. So I'm basically funded for this for 5 years in order to try to find some solution. But I'm happy to get input and discussion. That's why I'm also here. Yeah.
Okay, thank you.
But is there a web page you can see what we all have? Yeah.
Okay, no, and we are going to cut the line because we're supposed to.
Right, so first of all, thank you very much. It's very appreciated to see some lights in the life of the architect. Thank you. Now, I would have 2 comments. One, I think, is about very often as an architect, you propose a design and you don't know its limits. Where is it that I will have to destroy my design to go for something that gives me more flexibility? So that's one question. The second question is about something that took me 25 years to find in Russia, in the Academy of Science, actually. Is about the problem that goes with it is the aggregation of the choice, right? So you're going to end up with criteria like flexibility, security, performance, cost, stability, integratability, blah, blah, blah. Each of them are going to act like voters. And you're going to have a number of potential design, right? And so the problem, very often people think, oh, voting is simple, you just vote. But people lose track that mathematically you are going to have the result of the vote will be the result not just of the data, but as well on which aggregator you choose. I could prove you by ways that you would fix the data of each of those voting guys But depending the way you actually vote, you will change the results, or even worse, you will have no result. So it's interesting to see how, if we don't pay attention, we could lead to the wrong conclusion by choosing the wrong voting system. So now, to the point of how useful is this? Well, actually, I saw from a security perspective some labs, I will not mention them, or some operators that use this type of approach to calculate what's the best security answer in provisioning what. So what's the best design? So imagine when you're going to have, like in my country, Switzerland, let's say an operator with 5 million virtual machines, and they got a massive attack. Guess what? You will not be able to do it by hand. You will have a nice Fukushima effect in the country if you do that. So how the system can self-heal itself, find the right answer. So anyway, that was my thoughts. Perhaps it helps you. Next step.
Fully aware of that. So the aggregation is a big challenge. But if you go out today and think a little bit more deeply about flexibility, I'm already very happy. This is very complex.
Yeah, just a quick comment. And yeah,
Can you say your name and your affiliation, please?
yeah, Seoljun, Sungkyunkwan University in Korea. So you mentioned that about the flexibility with example of the migration. So, but to me, that it comes to me that like depending on the use cases, for example, latency sensitive application, maybe that VNF placement and the selection could be the proper measure of the flexibility. But just for simple load balancing or simple additional, for example, VNF creation cases, for example, the HTTP VNF server or MME, when more user is coming to their mobile laptop, at that time what we need is just the additional creation of the VNF. In that cases, flexibility will be just about that how the network can adaptively create dynamically its resources. So I think that flexibility, my point is that definition of the flexibility will be very depending on these use cases. So is that correct, or?
It is definitely use case dependent. Of course, this is what I said. You have to clearly say what kind of flexibility are you looking at. If it's the flexibility to accommodate new flows from a different distribution, then of course you have to fix how the system is looking like. How, if it's migration or if it's instantiation of functions or putting functions on distributed clouds, putting the function beforehand to the edge cloud, removing them, putting them centralized. This is then something that is on the cost balance. I think the two you have to take into account.
Another question is that the result you show is just a focus on the latency perspective as a measure of the flexibility, or any more constraint you just consider.
In this case, we looked at the latency as our performance goal.
Okay.
But of course, you have to fix the performance goal, the flexibility measure. But any system needs to have a goal, otherwise you will not build it.
Okay.
Just let me one thing. I know that we have a discussion on our future, but one of the things that they have had very often has been that the fact that we don't have long enough discussions during our meetings. So if you don't mind, I will let the discussion continue, and I would suggest, unless you have any objection or you want to make a very strong statement today in the room, just to leave the discussion about our future on the list. So we finish the technical discussion here. I guess that's taking advantage that Wolfgang is with us. Please.
I'm Hassan Halabian from Huawei, Canada. I think the merit of the work you presented is basically to quantify the flexibility as a separate performance criteria, right? So and then for network resource allocation or function placement or anything you want to call it, the idea is to basically come up with the objective function and then solve it, right?
Exactly.
So that flexibility is just giving another dimension to the objective function, right? Like
exactly.
Fairness is something that was not measurable, and then people define a fairness criteria, right? So the question is that have you ever tried to combine that performance criteria with other performance criteria like cost, right? Like operation cost or like capex or fairness, for example, and then come up with like a single problem, optimization problem?
So we have discussed this, and the question is, it's about aggregation. Yeah, I think we had this before. The flexibility definition is already quite complex, as we see from the discussion here. We have it in mind. We're thinking about it. There's always these discussions how to combine it with reliability. Was not mentioned before, for example. Security and so on. Of course, I would be happy, but I try first to go step by step in the project to give a clearly shaped understanding of this flexibility, but we have it in mind. In particular, the cost. This is the most urgent thing where we are currently working on.
So how much time do you have left for the project to finish?
And now in the second year of 5 years. So
okay,
there's more than 3
we have
years
3
to go.
years to go.
More
and,
than
well,
3 years, or 3.5 years to go. So
we'll call you back
I hope.
to report.
I'm happy to report, or
It will be.
if you have questions, send me an email. Yeah,
It will be even worse than going to Brussels. Yes.
Okay.
I have one more comment, Dendro to AT&T. To throw another wrench into your complexity, I think part of the factors to consider for flexibility is legacy support versus, greenfield. I think it's a totally different, or, you can call it hybrid design versus, new design. That has a significant factor. And in the end, the problem you're trying to solve is, there's a joke in the project management space, and I can extrapolate it with, like, you can have it fast, flexible, and cheap, but you can only choose two, right? So that's
Right.
Flexible and cheap.
Thanks.
Okay, Jeff, you're closing. No. You are the one closing.
So the proximity of our workload placement is quite interesting and relatively new phenomenon, but it's going all over the place. So in IETF, in routing space in IETF, we use function called PC, which uses number of objective functions to place a workload somewhere or instantiate parts of the workload. Have you looked into implementing of your work on top of PC that would use objective function to compute the best place to instantiate the workload?
PC is?
Path computation element.
A path computation element. We have thought about it. We have not implemented it on that one, I have to say. So far, this was more, let's say, on the ILP, solving optimization problems. We have not implemented it yet. We thought about it because some of these examples have been taken from work we did with vendors. We took these examples and re-evaluated flexibility. Right. So there's other publications. If you're more interested in the placement problem with different perspectives, also multi-objective optimization and so on, then check the website. There you will find things we have done. But as far as I know, it has not been implemented by our partners
It
yet.
would be very realistic use case.
No, of course.
Thank you.
Well, yeah. Still, well, if we run over 5 minutes, would be.
Have no clock, so you
Okay. Please.
So if we consider eNodeB, for example, let's say eNodeB.
Please, can you?
I'm Sahana. I'm also from the same university, Technical University of Munich.
Oh.
So if we consider eNodeB, for example, in a 4G network from two different vendors, and you say you have the same set of constraints, and then you can say eNodeB of this vendor is better than the other. But when you take the same eNodeB in 5G, probably the constraints are different. So are we also comparing for the same element across generations or across domains? This is one particular example, but this could happen for other cases, let's say a router or a switch or anything like that.
No, but comparing different systems designs across different generations wouldn't be a problem for the flexibility. What you need to keep is the requests that you put to the system. So the changes, the new requests. If you keep them the same, then you can compare also the designs of different generations. You can find out that maybe 4G, 4.5, 4.8G, whatever, is similarly flexible as 5G. But you have to define the question, what you would like to ask. What flexibility with respect to what aspect? This is very important. Otherwise, it doesn't work.
Okay, before anyone else steps up, thank you so much for them. Thank you so much to you all. If any of you have not signed the blue sheet, please do it on when you go out. Well, see you. Finally, since I announced this idea of shorter, more frequent meetings, we are planning to have interim meeting sometime in at the turn of the summer in September, October, probably September in the US precisely, and focus if we find a proper speakers on new design patterns for network functions. Just for you to know, you will be duly informed using the list. Thank you.
Diego. Yeah, sorry, Diego. Just one announcement. Yeah. On Thursday on the Bits and Bytes, I'm Robert Sabo, 5G Exchange project, and also working with Ericsson. So on Thursday afternoon at the Bits and Bytes, there will be a multi-provider network function virtualization demonstration.
Right.
And we're going to show various transport technologies, data center, networking, interconnected via an IP MPLS network with BGP VPN. So you are kindly invited to have a look at the Bits and Bytes demonstration. This is also related to network slicing. Thank you.
Hey, Robert, can you put that on the list, please? Thank you. Good.
So far, so good.
It went super fast.
Yeah.
Like too fast.
No, but it was, yeah, it's only 1 hour is too
little.
late. I told Alison, but Alison wanted to push us to the limit. So
Yeah.